Welcome back to my today's session. Today we are going to discuss some problems on time varying field. Myself, Dr. Sayanti Chatterjee, Associate Professor of EEE Department of Institute of Aeronautical Engineering. So, what is the Faraday's law? Whenever a conductor is placed in a time-varying field, an electromagnetic force is induced. So Michael Faraday is the father of electrical engineering, and based on his rule only, all the time-varying field AC systems are working. So Faraday's law is known as the whenever a conductor is placed in the varying magnetic field, an electromagnetic force is induced. If the conductor circuit is closed, a current will be induced, and this current is known as the induced current. So this rule is known as the first law of Faraday. Whenever if there is a conductor in a time varying magnetic field, so what the second rule tells? The induced EMF in a coil is equal to the rate of change of flux linkage. So what is this? The induced EMF in the coil is equal to the rate of change of flux linkage. If there is a flux linkage, some EMF will be induced. The induced EMF in the coil is equal to the rate of change of flux linkage. So if there is E is directly proportional to d phi by dt. If there is a rate of change of flux, the EMF will induced. And the third law, which is known as the Lenz's law, which states that the polarity of the induced EMF is such that it tends to oppose its cause. What does it mean? The polarity of the induced EMF is such that it tends to produce a current which opposes the change in the magnetic flux produced in it. So we can write the equation 3 at the time E is equal to minus n d phi by dt, where phi is the amount of flux. What is phi? Phi is equal to flux, E is equal to EMF, electromotive force, and what is the dt? Dt is the rate of change of flux. So we can tell E is equal to minus n d by dt into b dot ds. We can write E is equal to minus n b into ds. What is ds? Ds is the surface area, b is the flux density. B is the flux density. And what is ds? Ds is nothing but the surface area. B is the surface area. So we can also write E is equal to n minus n b ds by dt. We can write n is equal to b ds by dt. Again, we know that the E is equal to EMF is equal to potential is equal to minus E dot dl. We can write E is equal to minus E dot dl. So if we want to combine all the equation, we can write E is equal to minus integration of b ds by dt is equal to minus E dot dl. So we can also combine the two things so we can write also integration of del b by del t is equal to into ds E dot dl. This is the Maxwell's fourth law in the integral form. What is this? This is the Maxwell's fourth law. This is the Maxwell's fourth law in integral form. Now this side is ds, this side is dl. How we can change the ds to dl? We can use the Stokes theorem in this, and we can write grad cross E into ds using the Stokes theorem. using the Stokes theorem, we can write del B, and if we equate the two sides, we will get grad cross E is equal to del B by del T. And this is the Maxwell's fourth in the point form. This is the Maxwell's fourth equation in the point form. And this equation is also known as the modified or vector form of Faraday's law. Grad cross E is equal to del B by del T is known as the modified or vector form of the Faraday's law. So from this equation, today's total discussion is based on the two equations, Faraday's law and the Faraday's law in the vector form. We will solve some important problems on this. So we are moving to our first problem. So what is the first problem? A square loop of wire 50 cm into 50 cm in an alternating field with a maximum intensity is 10 ampere per meter. If the plane, so I will, 1 second, I will take one highlighter. So it is 10 ampere per meter. If the plane of the loop is perpendicular to the magnetic field and varying with at a frequency of 10 megahertz, find the induced EMF in the loop. So we have to find the induced EMF. So we are getting this from we can calculate the formula from the Faraday's law. So how to solve this problem? So first in the problem, it is given H is equal to 10 ampere per meter. So as this is ampere per meter, what does it means? Number of turns is equal to 1. So what is our basic formula? E is equal to d phi by dt. We have to use this formula. E is equal to, if we are not taking the direction, we are taking only the scalar magnitude. So what is B? We know B is equal to mu into H, because we have to calculate the phi and we have to again B dot ds. So first from the H we can calculate the mu. As there is the mu value is not given, we will take as mu naught. So it is 4 pi into 10 to the power minus 7 into 10. So we are getting the value 4 pi into 10 to the power minus 6. And what is the unit? Unit is Weber per meter square, or we can write the unit as Tesla. So if we get the value of B, what is phi? Phi is nothing but the B into A. Now what is the A cross sectional area? It is given the square loop is 50 centimeter into 50 centimeter. So B value is given 4 pi into 10 to the power minus 6. And what is the value? 50 centimeter into 50 centimeter means 2500 centimeter square. We are changing the centimeter square into meter square. So what is the value? So it is 100 B into A. So if we calculate it, 4 pi 100 pi into 10 square, 10 to the power minus 2 minus 6, 100 pi into 10 to the power minus 8, or pi into 10 to the power minus 4. So we got the value of 10 to the power minus 4. Now what is the frequency? What is the given? It is varying with a frequency of 10 megahertz. The frequency is given as 10 megahertz. So frequency is 10 megahertz means 10 megahertz. So 10 megahertz frequency means we have to calculate 1 by T. So frequency is equal to 1 by T. Now we know the value of phi, we know the frequency. So this value is pi into 10 to the power minus 4 into 1 by T is 10 into 10 to the power 6. So what is the value? Pi into 10 cube. So if we solve it, we will get this volt per meter. So this is the value of the time varying field. This is the induced EMF. The unit of the EMF is volt. So if we solve the value, we can get the, so it is 3.14 means if we solve it, we can get the value of the EMF. So this is the question number 1. First H is given. We can get the B from here. If we get the B, we can calculate the phi. Flux from here, B into A is equal to phi. Then we can calculate the frequency is given. Frequency means 1 by T. So 1 by T is the 10 megahertz. And what is E? E is equal to d phi by dt. Phi value we got, T value we got. So we can get the value of E. So this is our problem 1. Let's move to the problem 2. But before discussing the problem 2, we will discuss about the current density, displacement current density. What is the meaning of the current density? Current density means IC is equal to C. Current density is basically three types. Current density, first I write, current density is basically 3 types. One is the conduction current density, convection current density, and one is known as the displacement current density. So one is the displacement current density. What is the meaning of the conduction current density? Conduction current density means when current is flowing through a coil, there is some current density which is known as the conduction current density. In the case of the conduction current density, another one is the convection current density and another one is the displacement current density. What is the meaning of the conduction current density? Conduction current density means whenever current is flowing through any conductor, means due to some force like the voltage, electrons are moving through a conductor, the current will flow, and current per unit area is known as the conduction current density. What is the meaning of the convection of current density? We are giving one example. Without any force, when electrons are flowing in a medium, we will tell the convection current density. What is displacement current density? When current flows through any dielectric material, we can tell it as a displacement current density, and the magnitude of the displacement current density is very, very small with respect to the conduction current density. So basically in our daily life, we get the conduction current and displacement current density. If we think about about any circuit, it has 2 parts. One is resistance and one is capacitance. So when current is flowing, this is the IR is the conduction current, and current through the capacitor is known as the displacement current. Current through the resistor is known as the conduction current, and current through the capacitance is known as the displacement current. So what is the displacement current? Let us consider a capacitor connected to an AC source as shown in the figure. It is connected with an AC source as shown in the figure. So if the current has 2 parts, one is the IC and one is the IR. So IC, what is IC? If the voltage is V, IC is equal to C dV by dt. And what is C? C, we know epsilon A by D. What is epsilon A by D? A is the cross-sectional area D is the distance between the two plates. So we can write C is equal to epsilon A by D. So what is IC? IC is equal to epsilon A by D into dV by dt, capacitance by dV by dt. So what is the meaning of the current density? Current density means current per unit area. Current per unit area. So epsilon dE by dt. Now epsilon dE is equal to d by d into t. So Jc is the, what is Jc? Jc is the current density. And what is current density? D by d into dt. What is d? D is nothing but the electric flux density. What is dt? Dt is nothing but the electric flux density. So what is the total current? Total current I is equal to IR plus IC. I is equal to IR plus IC. So we got the main equation of the displacement current density. I is equal to IR plus IC. And what if we divide it by A, it will come J is equal to JR plus JC. JC is the displacement current density. And what is the meaning of the conduction current density? Conduction current density JR is always equals to sigma into E. What is JR? JR is always JR, or the conduction current density is always sigma into E. What is sigma? Sigma is nothing but the conductivity of the, what is JR or J? J is equal to conductivity of the medium. And what is the value of sigma? Sigma is equal to A by rho L. Rho L, we know that the sigma is equal to 1 by rho is equal to, what is the rho? Rho is equal to L by A. So we can get the value of 1 by rho. Rho is the resistivity of the resistor. Rho is the resistivity. So this is the equation we got from the displacement current density. So based on this, we will go for our next problem. Determine the conduction current. Determine the conduction current and displacement current densities in a material having the conductivity of 10 to the power minus 3 ohm per meter. Permittivity is 2.5 and if the electric field is E is equal to 5.8 10 to the power minus 6 sine 9 into 10 to the power 90 volt per meter. So we have to calculate the two things. One is the conduction current density and another one is the displacement current density. So in the previous section only we have discussed about the conduction current and displacement current. So what is the meaning of the conduction current? Conduction current density generally we write by J or JR is equal to sigma into E. What is the value of the sigma? Sigma is the conductivity and conductivity value is 10 to the power minus 3 ohm per meter. What is E? E is equal to 5.8 into 10 to the power minus 6 sine 9 into 10 to the power 90. So what is the value of the current density? The current density value is coming 5.8 into the sigma is 10 to the power minus 3 into 10 to the power minus 6 means 10 to the power minus 9 sine 9 into 10 to the power 90 and the unit is ampere per meter square. Now we will discuss about the displacement current density. Displacement current density generally we write by JC. And what is the formula of JC? JC is equal to D by D into dt. Already we have discussed in the previous slide. JC is equal to D by D by dt, where D is the electric flux density. So JC is equal to D by dt into D. Now in this problem D, the flux density is not given. We have to find out the flux density. how to get the flux density? We can get the flux density like D is equal to epsilon into E. We got the value D is equal to epsilon into E. What is epsilon? Epsilon naught epsilon R into E. What is epsilon? Epsilon naught epsilon R into E. Epsilon naught value we know 8.854 into 10 to the power minus 12. What is epsilon R? Epsilon value is given 2.5 into E. So if we get the value, so we can write it d by dt into 8.854. So first we write epsilon into E. Epsilon is a constant term, so we can write here 8.854 into 10 to the power minus 12 into 2.5 into d by dt of 5.8 into 10 to the power minus 9 sine 9 into 10 to the power 9 t. So if we solve this equation, this is again constant. So 8.854 into 10 to the power minus 12 into 2.5 into 5.8 into 10 to the power 9 ddt of sine omega t. So omega sine cos omega t. So 9 into, this is minus 9, 10 to the power 9. Then cos, the definition of the cos 9 into 10 to the power 9 t. So 10 to the power minus 9, 10 to the power minus 9 will cancel out each other, and if we solve this problem, we can get the value of the JC, the current density of a displacement current. So this is the problem number 2. So how we can calculate? The calculation of the conduction current is very easy. How to get the conduction current? J equals to sigma E. So sigma is equal to, what is sigma? Sigma value is given here. So if we write the value of the sigma into E value is given. Next is the calculation of the JC. How to calculate the JC value? We know the displacement current density. JC is equal to D by dt. So how to calculate the value of D? D value is not given in the problem. So we can get that D is equal to epsilon into E. What is the epsilon? Epsilon means permittivity. So epsilon naught epsilon R into E. Epsilon naught value we know. Epsilon R value is given in the problem. So what is JC? D by dt into epsilon E. So epsilon value is given D by dt into E. So if we differentiate it, we can get the value of the displacement current density, and the unit is ampere per meter square. It is very important to calculate the current density in every moment. So this is the ampere per meter square current density. So this is our problem 2. Now we can move to our problem. First we will move to the EMF, types of induced EMF. This is also one important topic. Before discussing the problem, I will discuss the topic. What is the induced EMF? Induced EMF can be divided into 2 parts. One is the dynamically induced EMF. Another one is the dynamically induced EMF, or the another name of this is the generator EMF. So what is the generated EMF? Generated EMF means the magnetic field is constant and the conductors are moving. Let's think about a generator, about a DC generator. North pole and south pole is in the stator portion. So there is some electric lines of force. Now if we, with a prime mover, if we rotate the armature, what will happen? Some current will come. So intensity E is equal to BVL sin theta, and then we are getting the value E is equal to BVL sin theta. The potential induced can be written as the E is equal to B V L. L is the length of the conductor into sine theta. And what is the maximum value of the potential? The maximum value of the potential is E when theta is equal to 90 degree, and the value will come E is equal to B P into L, or B is the flux density, V is the velocity, L is the length of the conductor. And how we can get this? E is equal to d phi by dt, and if we step by step we put the value, we will get the value of the EMF. Next one is the statically induced EMF. What is the meaning of the statically induced EMF? If any conductor experience a variable flux, means the conductors are fixed. Just unlike the dynamical induced EMF, the conductors are fixed and the flux is rotating. So we can write it as the statically induced EMF. So E is equal to minus N d phi m by phi m sin omega t. If we take the flux is in a pure sinusoidal, and the equation is phi m sin omega t, we can write E is equal to minus N d phi m sin omega t by dt. So what is the meaning of the E? Or we can write it as the minus N phi m omega cos omega t. And when the value of the omega is equal to 0 degree, we will get the maximum value of the intensity. So based on these equations, we will discuss the another problem. A conductor of length 100 cm. So one conductor whose length is 100 cm. 100 cm means 1 meter. Moves at a right angle to a uniform field of strength 10,000 lines per meter square. 10,000 lines means electric lines of flux. In one word, it is called as the 10,000 lines per centimeter square. So in one word, it is known as the electric flux. So electric flux psi is equal to 10,000. Electric flux psi is equal to 10,000 coulomb per meter square. So we can change it in the in the coulomb centimeter square. So we can change it into the meter square. So this is the flux per meter square, means actually this is not the flux psi by A. So this is the flux density B. We got the flux density B. So what is the speed? The speed is known as the E is equal to V L V sin theta. B value we can get from here. B value we can get from here. L value is the 1 meter. V value is given in the problem. The V value is 50 meters per second. 50 meters per second. So if we get the value of B, we get the value of L. B is the maximum. So when it is maximum, when theta is equal to 90 degree, the E will be BLV. So this is the case 1. What is the case 2? Case 2 is telling when the value of the theta is equal to 30 degree, we will get E is equal to BLV sin theta. Again, B value is given. If B value is given, L value is given. The velocity V is equal to 50 meter per second. Sin theta, theta is equal to 30 degree. So if we put the value, we will get the value of the intensity. So this is the case 2. E is equal to BLV sin theta. So now I am moving to the fourth problem. What is the fourth problem? In a material for which sigma again, what is sigma? Sigma is equal to nothing but the conductivity is 5 ohm per meter, and the sigma r, and we can write it as the epsilon r also. The permittivity is 1. The electric field intensity is 250 sine 10 to the power 20 volt per meter. Calculate the conduction current and displacement current density and frequency at which they have the equal magnitude. So the first part is same as the before we discussed the question. So how to solve this problem? So first one is the current density J. J is equal to sigma into E. Sigma value is given, E value is given. So it is coming 5 into 250 sine 10 to the power 10t. 10 to the power 10t. So it is coming 1250 sine 10 to the power 10t volt. Ampere per meter square. So we got the current density. Again, in the problem we have to calculate the displacement current, d by dt. Now what is d? D is equal to d by dt into epsilon e. Epsilon is constant, so de by dt. What is epsilon? Epsilon 0 into epsilon r. Here epsilon r is 1. So d by dt, what is E? E is equal to 250 sine 10 to the power 10 omega t. So epsilon 0 is 8.854 into 10 to the power minus 12. What is the 250 is also constant. So it is the omega cos 10 to the power 10t. So if we solve this equation, we will get the value of the J. See, if we solve the equation, we will get the value of the J. See, the conduction current density. Now, if we want to move in the, so this is the displacement current density. Now, we are moving to this equation. Calculate the frequency at which they have equal magnitude. Calculate the frequency at which they have the equal magnitude. How to calculate the equation? So both are equal, means in that case J is equal to JC. We can also write it sigma E is equal to what is JC? JC is equal to d by d into dt. We can write this is our part 1, this is our part 2. So we can write sigma E is equal to d by dt. 1 by t is nothing but the frequency. So we can write omega into d. What is the value of omega into d? What is omega? Omega is equal to omega is the frequency. Why we took omega? Because it is a rotating field. This field is a rotating field. That's why we are writing the omega, not f. Omega is a rotating field. So what is 2 pi f into d? We can write omega is equal to 2 pi f into d. Now what is d? D is nothing but the epsilon into e. So we can write here 2 pi f epsilon into e. So both side e will cancel out. So we can write f. F is equal to sigma by 2 pi epsilon. What is the value of sigma? 5 by 2 into pi into sigma epsilon is equal to epsilon naught epsilon r. What is epsilon? Epsilon naught epsilon r. Epsilon r is given 1. So it is 8.854 into 10 to the power minus 12. If we solve this, we can get the value of the frequency at which the equation is the J conduction current density and the displacement current density both will be equal. So what is the equation? What we did? First part is very easy. J is equal to sigma E. Sigma value is equal to 5 into 250 sine 10 to the power 10 t. And what is J? J is equal to d by dt. So what is d? D is nothing but the sigma E. So sigma is equal to dE by dt. Sigma naught, sigma r, d by dt 250 sine omega t. So epsilon naught value is 8.854 into 10 to the power minus 12. Epsilon r is equal to 250 cos 10 to the power 10 cos 10 to the power 10 t. So if we solve, we can get the value of the Jc. What is the frequency? Frequency F is equal to sigma by 2 pi epsilon naught epsilon r. So if we put, because sigma E is equal to d by dt, d by 1 by t is nothing but the omega, so 2 pi f d. So what is F? Sigma by 2 pi d. So d value means again d is equal to epsilon E. So E cancel out. So sigma is equal to 2 pi epsilon naught epsilon r. If we put the value, we will get the value of the frequency. So this is the problem 4. Next, we will jump to the problem 7. A square loop of wire 25 cm into 25 cm are placed in an alternating field with the maximum intensity of 1 ampere per meter. If the plane of the loop is perpendicular to the magnetic field and varying at a frequency of 10 MHz, find the induced EMF in the loop. Then what is this? Cross-sectional area is given at 25 into 25 centimeter square, means 625 centimeter square is equal to 625 into 10 to the power minus 4 meter square. What is H? H is given as the 1 ampere per meter. So what is B? B is equal to mu naught into H is equal to 4 pi into 10 to the power minus 7 into 1, means 4 pi into 10 to the power minus 7 Tesla or Weber per meter square. So what is the flux? Flux is equal to B into A. What is the value of the B? B value we got as 4 pi into 10 to the power minus 7. What is the value of A? A value we got 625 into 10 to the power minus 4. So after multiplying these two equation, 5 4s are 20, 4 9 4 20 10 6 2500 into 10 to the power minus 11 or 25 into 10 to the power minus 9 Weber is the flux. So what is the frequency? Frequency is 10 megahertz. 10 megahertz means 1 by t is equal to 10 into 10 to the power 6 hertz. So what is the EMF? EMF value we know d phi by dt. Phi value is 25 into 10 to the power minus 9. Frequency 1 by t is equal to 10 into 10 to the power 6. So the value is coming 25 into 10 to the power minus 2 volt or 0.25 volt. So we got the EMF as 0.25 volt. So again the question is same. If we know the value of the H, H is equal to H, we have to calculate if we are using the Faraday's law d phi by dt. How to get the phi? B into A. How to get the value of the B? B is equal to mu not H. So H value is given in the problem. We have the value of mu. So mu not 4 pi into 10 to the power minus 7 into 1. We got the H value. So phi is equal to B into A. So if we put the value, we will get the phi. A value is given in the problem. Then the frequency value is given as 10 megahertz. 10 megahertz is equal to 1 by t, 10 into 10 to the power 6. So E is equal to d phi by dt. And if we put the value, we will get the value of the EMF. So we have the more problem on the time varying field. And thank you.
Like, share and subscribe. Hit the bell icon for more updates.